In this video we're going to look at the way that we can, in particular the way that we can multiply algebraic expressions together and sometimes factorize algebraic expressions. But before we get to that, we should perhaps look at some vocabulary. A polynomial is just anything that kind of looks like this. So if it's all powers of x, so x to the power of 5, x to the power of 3, x to the power of 2 and so on, with 2, some kind of constant at the end, then that's an example of a polynomial. You can't have, for example, 6 to the power of x. That would then not be a polynomial any longer. Okay, so this is an example of a polynomial. The 2 is the constant term. We say that look at the highest power is 5, and so we can say that the polynomial is of degree 5. And the coefficient of the x cubed term is 6, the coefficient of the x squared term is -4, and the constant term is 2. It's very easy to add or subtract polynomials. You'll remember that we have to deal with like terms, so the 4x cubed in this example would be added to the 3x cubed over here to make 7x cubed. And the same thing goes for the x squared terms, the x terms, and the constant terms. They get added on to each other also. When we have subtraction, remember that if you've got subtracting a whole polynomial, that you've got to subtract 2x to the power of 4. You've also got to subtract the 4x squared. You've got to subtract negative 2x, which means adding 2x. And that's why you've got x plus 2x making 3x there. So you've got to remember to do the opposite of whatever the sign is in here if we have a negative before it. Now you remember probably that it's possible to multiply algebraic expressions. For example, we have an expression here, a plus b times c plus d. You've got to do the c plus d first of all times the a, and then do the c plus d times the b. So a times c plus d plus b times c plus d. And if you do that, you'll get ac, you'll get ad, you'll get bc, and you'll get bd. And a way of remembering it is that the ac is the first terms of these expressions, the ad is the outer term of these expressions, the ad. The bc is the inner terms of this whole expression here, and the bd is the last term of both. It's possible to think about this geometrically. If we have some kind of drawing like this, a rectangle, you can get the total area by doing a plus b times c plus d. Right? So the total area of this thing is a plus b times c plus d. But it would also be possible to take the individual areas of these 4 parts, that's AC, AD, BC, and BD, and just add those things together. So another way of thinking about it is that it's AC plus AD plus BC plus BD. Okay, and that tells us, it's another way of knowing that this expression is true. Now try these 2 examples for yourselves. See if you can multiply these together. Pause the video and then play the video again to see the answers. Okay, in this first one we do the 3x times the 5x to get 15x squared, the 3x times the 1 to get 3x, the 2 times the 5x to get 10x, and the 2 times the 1 to get 2. If you do that, and if you gather together the x terms, you get 13x in the middle. In the second one, you have to multiply each of these terms here by 2x, and you've got to multiply each of these 3 terms by -1. And if you do that, what we should get is the 2x times those things, 2x times the thing on the right, and then you've also got to remember then to do -1 times those things. Multiplying out the brackets gives you this, and then gathering, for example, the x squared terms together gives you this. Now there are some products that are important that happen quite a lot. For example, we quite often have a plus b or x plus y squared, and so it's useful to be familiar with what kind of answer that will give us. And if you do a plus b times a plus b, what you get is this. And if you gather together those ab's, you'll get this thing, a squared plus 2ab plus b squared. And a similar kind of thing happens for a minus b all squared. And then when we have a plus b times a minus b, something quite interesting happens. The minus ab that we get from doing a times minus b cancels out with the ab that we get from here. So we end up, in a case like this, just having a squared minus b squared. So give yourself a couple of minutes to try to multiply these expressions here using the rules that we have above, using these rules in here, find answers for or simplifications of each of these. Well, for x plus 4 squared, that's an example like this first one. So it's your a in this case is going to be x, and your b in this case is going to be 4. So we're going to have x squared plus 2 times x times 4 plus 4 squared. And if you simplify that, you get this. For the second one, it's like this example here. So we've got to do, we're going to have a equals to 3x and b equal to 5y. So we'll get this expression, and when you simplify that, you should get this. And then the last one is the nicest one. Effectively here, it's like this example here, but your a is 2p and your b is 9q. So we're going to have 2p all squared minus 9q all squared. Like this. And if you simplify that, 2p all squared is going to be 4p squared, and 9 squared is 81, so we have minus 81q squared. Now, I don't think you should have many problems with example 6. You just look for the thing that goes into 3x squared and also goes into minus 6x. That thing is 3x, so it's 3x times x minus 2. In the second example, you look for the highest power that goes into each of these terms. That's y to the power of 2. And there's also a number that goes into 12, 10, and 6. So it's 2. So it's going to be 2y squared, the factor. And if you do that, you get 2y squared times, well, 2y squared times what gives you the 12y, the 12y to the power of 5. You need to find 6y cubed there. Now, if you want to factorize these kinds of things, for example, if you want to factorize 4x squared minus 9, you can remember that something squared minus something squared can be written like this. So you have to rewrite 4x squared minus 9 as 2x all squared minus 3 squared. And then it's a case of using this formula, but with a equals 2x and b equals to 3. So sometimes it's easy like that, but sometimes it can be a little bit more difficult. in this example here, you have to look for two numbers that multiply to give 6 and add to give 5. So one way of setting it up is to think of there being x plus 1 on the top, x plus 6 on the bottom, and try just crossing the x and the 6 and the 1 in the x to get 6x and 1x. Unfortunately, they don't add up to 5x, they add up to 7x, so this thing here is wrong. However, if you try another two numbers that multiply to give 6, try 2 and 3, well, the x times 3 and the x times 2 give us this, and those add up to 5x. So this would be correct. This x plus 2 times x plus 3 gives us this. Basically, you're looking for two numbers that multiply to give 6 and add to give 5. And this works whenever the first term is x squared. If you've got x squared plus some number times x plus a number. Similarly, in example 8, you can just look for two numbers that multiply to give negative 8 and add to give negative 2. You can see that these negative 1 and 8 don't work because they add up to 7x. Negative 2 and 4 add up to 2x. That's no good. The only one that works, two numbers that multiply to give negative 8 and add to give negative 2, it's these ones here. Right, so this would be the correct factorization. Now on page 4 there's a slightly more difficult one because there's more than one thing that can multiply together to give you 6x. So we've got trials of 6x and x, we've also got trials of 2x and 3x, and over here are all the different ways that you could multiply numbers to get negative 3. So in this example here, you're trying 6x minus 1 times x plus 3. The 6x times 3 and the negative 1 times x don't add up to what we need. We need negative 7x, but it's 17x. And you can try all of these. 2x minus 1 times 3x plus 3 also gives you something that's not quite negative 7x. But this one here does work because 2x times 1 is 2x, 3x times minus 3 is negative 9x, 2x minus 9x is negative 7x, and that's exactly what we want. Now lastly, we can use those special kind of cases, the a plus b squared and the a minus b squared and the difference of squares, one down here, to factorize these types of expressions. Try those now and then come back to see the answers after 2 minutes. Well, for the first one, we could rewrite that like this: x squared plus 2 times x times 3, which looks a little bit like this thing here, but with a equal to x and b equal to 3. So we can rewrite that as x plus 3 squared. The second one looks, if you rewrite it like this, looks a little bit like this second example here, but with the a equal to 2x and the b equal to 5. A, 2x, b, and 5. So, since that's the case, it's going to be 2x minus 5 all squared. And the last one, this one down here, well, the first thing we can do is we can look at these two values, 12 and 27, and think, is there a number that goes into both of those? And yes, that number is 3. And then we can look at this 4x squared and this 9 and think, okay, well, this 4x squared here is just 2x all squared, and 9 is 3 squared. So another way of writing that would be like this: 2x all squared minus 3 squared. And then this thing here is really the same as this, but with a equal to 2x and b equal to 3. So we can factorize it like this. So it's 2x plus 3, 2x minus 3. And that's what we have here.